All right, so 2018, number 5. Let f be the function f of x equals e to the x cosine of x. Find the average rate of change of f on the interval 0 to pi. That's average rate of change. So that's actually like really easy. It's the average slope. So just start minus n over distance. B, what is the slope of the line tangent to the graph at x equals 3 pi over 2? Find the derivative, plug in 3 pi over 2. C, find the absolute minimum value of f on the interval of 0 to 2 pi. So you're essentially going to find all the critical values where the derivative is equal to 0. Throw in the endpoints into that set and test everything to see what's the smallest. And then D is the tricky one that we'll spend a lot more time on. All right, so let's look at A. Average rate of change on the interval 0 to pi. So A, f of x equals e to the x cosine of x. So the average rate of change will be f of pi minus f of 0 over pi minus 0. F of pi in this case is e to the pi cosine of pi. Cosine of pi is, cosine of 0 is 1. Pi over 2 pi would be 1, so this will be negative 1. Minus f of 0, so that's minus e to the 0 will be 1. And then cosine of 0 will also be 1. So we have negative e to the pi minus 1 over pi. And that's really as much as you're going to do. B, slope at x equals at 3 pi over 2. So to take our derivative, we'll need the product rule. Derivative of e to the x is e to the x plus e to the x times the derivative of cosine. So we plug in 3 pi over 2. All right, let's factor out an e to the x. All right, so cosine of 3 pi over 2, that's that one, that's 0. Sine of 3 pi over 2, that'd be negative 1. So it'd be e to the 3 pi over 2. All right. For C, the absolute minimum, we're going to find, so we have the derivative. We want to find the places where the derivative is equal to 0. And and 0 and 2 pi. So we already have the derivative, thankfully. So we just have to see where this is going to be equal to 0. This will never be equal to 0 because it's e to the x. This will be equal to 0 when cosine is equal to sine. Where does that happen? Oh, yeah. So like this is actually quite handy. Those are the spots where it happens. This one is pi over 4, and that's going to be 3 pi over 2 minus pi over 4, whatever that is, 6 pi, 5 pi over 4. Okay, so we've got 0, we've got pi over 4, we got 5 pi over 4, and we got 2 pi. Then we got to plug these into our original function to see which one is the smallest, because we're looking for the absolute minimum. Alright, so this is x. We want f of x. When I plug in 0, I get 1. And cosine of 0 is also equal to 1. We'll have e to the pi over 4 times cosine of pi over 4, which is square root of 2 over 2. E to the 5 pi over 4 times cosine of 5 pi over 4, which is negative square root of 2 over 2. And 2 pi, so we'll have e to the 2 pi, and cosine of 2 pi, which is 1. This is clearly the smallest, because that's negative. Like, if you're doing this and you get something where you're not sure, like you have to do calculations, like we actually care what that value is. If we were comparing this to this, we would have a difficult time of it. I mean, in this case, like this is going to be greater than this because this is going to be a value, and then it's going to go up to the maximum and down to the minimum. But like if you actually had to compare those, you're probably doing something wrong, or there's a simplification you missed. But like this is clearly the smallest because it's negative, and that's the absolute minimum. And these are the critical values. That's our justification. All right, let's look at D. Let g be a differentiable function such that g of pi over 2 equals 0. The graph of g prime is shown below. Find the value of the limit as x approaches pi over 2 of f of x over g of x, or state that it does not exist. Justify your answer. All right, so there's a couple things going on here. First, we are going to try to evaluate the limit by substitution. If we try to evaluate that by substitution, f of pi over 2 is 0. E to the pi over 2 times cosine of pi over 2. Cosine of pi over 2 is 0. So we get 0. And g of pi over 2 is also 0 because it says that g of pi over 2 is 0. So this is not going to work. We cannot do it by substitution. So we're going to try, specifically because we have a ratio and it's 0 over 0, we're going to try L'Hopital's rule. So D. All right, limit. As x approaches pi over 2, they're telling me to vote tomorrow, of f of x over g of x, so f of pi over 2 that's 0 over 0. We can't do it by substitution. So we're going to try L'Hopital's rule, which says that it is also equal to the limit as x approaches pi over 2 of f prime over g prime. So now we have to find these values. F prime of pi over 2 and g prime of pi over 2. F prime of pi over 2, we're going to look at our derivative up above. It was e to the x cosine of x minus sine of x. So this will be e to the pi over 2. Cosine of pi over 2 was 0. Sine of pi over 2 was 1. Over g prime of pi over 2. This is where we have to look back and see more about g. We're given a graph. G prime of pi over 2 is just 2. right? This is the graph of g prime. G prime of pi over 2 is 2. So over 2. So we have negative e to the pi over 2 over 2.